Hello, everyone. Let's wait for 5 more minutes to see that people are still joining. And I just wanted to say that tomorrow, at least by 9 a.m. or 9:05 at least, please join early so that we can start the sessions early. Okay. Hi, Ashok Kumar. The demo sessions are completed. Okay. And we are about to begin the actual sessions from today. And I don't know if 7 sessions have happened. I don't know how you are waiting for almost 2 weeks. That's one question from my side. Only 7 sessions have happened. How you are waiting for 2 weeks? That's really strange from my side. Let me see because okay. Well, jokes apart, Ashok Kumar, because since we have only arranged 7 demo sessions, okay, so today the actual sessions are going to be started, but with the theoretical scenarios. Today we will discuss about Docker in theoretical, and we will do it practically tomorrow. Okay. Yes, right, Ashok Kumar. You're right. Okay, I just wanted to wait for 2 to 3 minutes more, and let's clarify to all the people that sessions are going to be started exactly at 9 a.m. from tomorrow, or at least by 9:05, so that we can close the session at least by 10:15 or 10:20, and then probably we can have a Q&A session from everyone. Okay. So today, most probably I will discuss theory part, because since for all the demo sessions I was doing practicals, theory is really required in terms of when we are actually learning some new technologies like Docker today. So we'll just analyze some static terms using Docker today, and then probably we will do hands-on from tomorrow. Okay, so that's the total idea. I know that people will not understand this Docker part today, but if they are going to come tomorrow, then probably they will understand most of the things. Docker is really complex to understand, and some of the terms are really challenging, but I will make you very much easy from tomorrow, not from today, because today I just have to concentrate on some theoretical lecture on Docker. Okay, I think there are almost 40 plus candidates. So my request to all 40 plus candidates, okay? So please join the session at least by 9 or 9:05 a.m. from tomorrow, because I don't want to wait this much long in order to start the sessions, okay? So it's a kind request to everyone. So kindly join the sessions tomorrow by at least 9 a.m. itself, okay? Yeah, thank you so much. And let me share my screen first of all. And I just wanted to start with Docker first of all. Let me share my screen. Is my screen visible to everyone? Can you please confirm? Thank you so much. Yeah. Okay, so don't worry about today's lecture because it's completely theory. Okay, because it's almost been 9:30. I'll take just 30 minutes of your time today, and probably tomorrow we'll just concentrate on the complete hands-on approach, where we'll be actually using Docker in order to build our Spring Boot applications. Okay, so don't worry about that. So first of all, what is Docker? Anyone knows about Docker, first of all? Okay. So let me tell you in a more simplex way, simple way, and also we will just see some example hands-on from tomorrow. What is this Docker and what type of security Docker is going to provide to our Spring Boot applications? Okay. So first of all, Docker is a containerization technology. That means we also call it as containerization platform to package our applications. Okay. So what is a containerization technology? Okay. So in Docker, we do have two specific terms. One is the image and one is the container. So right now, if you just go and develop a Spring Boot application, when we actually build the application, everyone knows how to build a Spring Boot application. I'll just show it to you in a bit. So let's say I just wanted to select only the web. This is just to explain Docker, some parts theoretically. So here I just wanted to name this as, let's make it as demo itself, and then probably just go to this demos, and also I will remove this one. Yeah. So here, this is a demo Spring Boot application, and just click on generate. Okay. So here, what you can do, you can just go to this. And also, I will tell you about IntelliJ on how to use IntelliJ IDE once we cover Docker. Okay. Just wait for some time. It is scanning files to basically index this Java application, the Spring Boot application, Maven project. So here I just wanted to create a simple class and name it as test controller. And here, just a simple test controller to explain about Docker, not explain about Spring Boot application. Simple get mapping. And here I just wanted to make sure that server.port is 9097. Okay. And I just wanted to start this application. So here, when we are actually starting our application, we are actually manually restarting it, right? But what happens, let's say if we actually wanted to deploy this application on a cloud or any other environment to make it live? Because what happens if we just have to deploy this application live? That means lively it has to be, right? Then probably we cannot run this application like this, run as demo Java application, because if you just go and right click on this project, there is something called Open in Explorer. So here, if you can see that there is a target folder, but right now I just want to remove it. So right now we are actually running this application as a Java application like this. Okay. Now I have to start my application. Let's say if there are 10 demo applications or 20 demo applications or 30 plus Spring Boot applications. Can we go and run like this every time? There has to be some automated way. Docker provides you that. Okay, I'll tell you all those kind of things, but not right now. Tomorrow we will see hands-on. But I just wanted to explain one more thing. So here, if you can just see that, let's say I just wanted to go to this Open in Explorer. I think I have already opened it. Yeah. So here, if I have to give this application to anyone, what they basically do? Do I have to give all these folders to them, or do we give them as a package of our application? So how we are going to give this application to other end users who are basically clients to actually run our application. So how to provide this application as a package to the end user client so that he can use it. Anyone knows about it, first of all? Yes, package as jar or var, right? So what we basically do, we just open the terminal, and then probably I just wanted to run one command, which is something called maven clean install. So this is basically to build a Java Maven project. Even if it is a Spring Boot or Spring Cloud project, we basically use Maven clean install, and then probably it will generate a jar file inside the target. If you see that there is no target folder over here, I just wanted to run this application. That means I just wanted to build my application using MVN clean install. And then probably once you run it, it will just build our application. And it will generate a target folder where we can see the jar file. Yes, the build is success. Now, if you just go to this target, this is the file. You have to share it with your end user client or the client. Okay, so let's copy this jar. And paste it in documents for now. And I just wanted to show more options. 7-zip, extract here. Okay, sorry, I just wanted to do show more options. Extract to user registration snapshot. Yeah. So now if you can see that you have some org, Spring Framework, boot, and loader, and you have some executable .class files over here. But here, where are your files? Everything will be encrypted. Okay, so this is something called a jar file provider. So inside the jar file, we will not be able to get any source code informations. Okay, and here, if you just go to this documents, just wanted to go back again. Yeah. So this is the file that means this is the jar file that we are going to give to the end user so that he can run this jar using the Java command. Okay. So I just wanted to stop this application here, first of all. And I just wanted to go to the command prompt. And I just wanted to clear the screen. I just wanted to go inside the target where our jar file is actually present. And here I just wanted to run java-jar and the demo -0.0.1-snapshot.jar, and you can run like this. Okay, so this is how basically we actually run our Spring Boot applications on different environments. But this is the manual setup, right? This is, see, whatever we are doing here, if you just go to this, we are just running it manually. But here we are actually doing something different. We are not running the main class. Here we are actually executing a jar file. But still, this has to be eliminated because if there are 20+ applications, we cannot do java-jar every time, right? So Docker is going to make it simple to run our applications in sequence. How to run our applications as jar or var, how it is like. So everything is going to be provided by Docker. So with Docker, we can run these commands in an automated way using Docker Compose tool. But tomorrow I will explain about Docker Compose tool later on, but not right now. I just wanted to stop this application again. And this is one way of Docker, using Docker. And now, if I run this application, let's say if I just wanted to run this application, I can just run it, right? But let's say there is only one demo application which is running, and there are so many users, let's say 50 users are there, and 50 users can hit this test controller endpoint from their own side. Okay. Now, what happens? This application has certain CPU. This application is running on my machine. My machine has a certain CPU, right? So let's say 50 requests are being served, 100 plus, 200 plus requests, fine. 300 plus, 500 plus, fine. Let's say 1 million requests. Will my test controller is going to handle 1 million plus requests or not? That's the question. Yes. So there is something called a load. Let's say as a human being, I can actually lift some certain amount of weight. If it exceeds, what will happen? The person will die, right? The same way, application is also going to behave the same way. So now the problem is how to make this application to run 2 times on different ports. Anyone knows about it? First of all, how to run this application on different ports. I just wanted to run 2 instances of this application. Anyone? No. See, if I change the port number, I have to restart my application again, right? So it will run on 9091. Let's say I just wanted to mention it as 9091. It will run on only 9091. This application has to be stopped. But is there any other way in IDE? So here you have something called edit configurations. And here I just wanted to create one more instance of the demo application. Select application. And here give the name of the application as demo application instance 2. And the main class is the demo application itself. And here I just wanted to give the environment variables as server.port equal to 9091. And then probably you can click on apply and close. So here I just wanted to rename this to demo application instance 1. Now click on apply and click on close. Now I have 2 instances of this application running. One is a demo application instance 1 and a demo application instance 2. So I can just, so demo application instance is already running. So I just wanted to start this demo application. And now if you can see that this is a demo application instance 2 is running, and this will run basically on 9091 port. Here, basically we are actually, let's say if there are 100 requests, 50 requests can be served by demo application 1 instance, and 50 another request can be served by demo application instance 2. So here we are actually balancing the load between multiple instances of our application running on the same machine, right? So here we are actually after running first time. Okay, fine. So here let me stop this first of all, and let me start it again because I have renamed it, right? Start it. Okay. Now demo instance 1 is running on port 9091 and 9090, and this instance is running on 9091. So what I can just go and do, localhost 9090/test, and we'll get the result 9091/test. But how we can do the load balancing? Here we cannot do the load balancing since there are 2 applications running, demo application instance 1 and demo application instance 2. Let's say there are 6 requests coming in at the same time. 3 requests has to be served by demo application instance 1 and 3 application requests has to be served by demo application instance 2. If we have to make this run, we need to use one of the artifact provided by Spring Cloud, which is a Eureka server. Yeah. Okay, but we will discuss those things in a later stage. But right now we are actually concerned about Docker. So here, basically, if I just wanted to create another instance again, I just have to go click on plus, click on application, and click on demo application instance 3. And then the main class is demo application. And then probably I will give server dot port 9092. Click on apply and click on OK. Now I can just start this demo application 3 also, which will run on 9092. Okay, so I have this many number of applications. Let's say 3 applications is fine for 100 or 200 or 300 or even 1000 requests. But what will happen in real time? We will get a lot of load, right? So we need to scale the instances up. That means increase the instances as well as decrease the instances once the load is very low. We cannot keep 3 instances running for 1 or 2 requests over here, right? So how we can do that? So we can do that automatically by using Docker. So that's the specific purpose why we need to use Docker. So Docker provides scalability. Dockers are going to have 2 specific terms. One is a Docker image and another one is a Docker container. So if you just see the jar file over here in the target. So right now we call it as a jar, but in Docker, when we actually build the application using Docker command, we actually call it as an image instead of a jar. So that image will have a jar inside it and it knows how to run it, but we need to give some instructions on how to run that Docker image as an application. Okay. Now, I just want to go to the PowerPoint presentation again. I just wanted to. Yeah. Okay. So, and one more thing, Docker is lightweight and fast. Okay. So, what I have said in the first point, Docker is a containerization technology. That means it's a containerization platform to package your applications. What is a package basically? Jar is a package which contains classes, packages, right? And the dependencies that are defined in pom.xml. Everything will come as a package, right? So this Docker container is something like why it is a containerization platform. There are 2 terms in Docker. One is a Docker image and another one is a Docker container. Both are same. Let's say when we actually call it as a Docker image, right now, when we actually build the application using Maven clean install, you have seen a jar. Like the same way, when we actually build the Docker using the Docker command to build a Docker image, we actually call it as jar, but alternative in Docker, we call it as an image. Jar alternative is Docker image, which contains the jar along with classes, artifacts, and etc. Now, previously, we know that people were using virtual machines. Docker was not there in the market. People were using virtual machines. What happens with the virtual machines? Virtual machine requires a complete OS to be installed. Otherwise, virtual machine will not be there. Virtual machine requires a OS. But here, Docker did not require an operating system, but it actually required some support from the operating system. That's why Docker containers are lightweight, because they do not require operating system to be installed on our machine. It actually takes the help of our operating system to install Docker. That's why they are lightweight and they are very much fast. I will tell you how fast they are in a practical example. And there is something called Docker images. So a Docker image is a standalone executable package, just like a jar, that includes everything needed to run a piece of software, including the code. That means the Java source code, runtime. What is this runtime? Yes, the JDK runtime environment, and libraries. The pom.xml we have provided as a dependencies. These are all called libraries. And environment variables. Environment variables are related to server.port, spring.data source.username, URL, password. All these kind of things are environment variables. And then probably we do have something called configuration files. That means the classes which are annotated with @ configuration. Okay. So all these things are part of Docker image. So Docker image is just an alternative for a jar file. Jar is also a package, Docker image is also a package, but in Docker we call it as an image. But when we actually run a jar file, it actually becomes a Java application, right? But in Docker, when we actually run this Docker image, it actually becomes a container, Docker container. That means an image is a Docker image. When it is going to run, it obviously becomes a Docker container. So anyone knows about container? What is a container, first of all?
Just like bean container.
Yes, just like, so a container is a platform provided by Docker by taking the help of our operating system. First of all, I just wanted to show 4 different resources. I will just go to the task manager. So can you see here, there are 4 different resources. One is CPU, one is memory, another one is disk, and another one is network. So Docker exactly depends on these 4 resources to install Docker. So when we have to install Docker on our machine is actually having OS, but Docker doesn't need a OS. It actually requires certain core part of the operating system. Only 4 resources it actually needs. One is the CPU, another one is memory, disk, and at last network. Docker actually needs these 4 resources to make or create a Docker environment. That's all. That's the total idea. Now, what is the Docker container? So when I say that Docker image, when it is going to run, it obviously becomes a container, right? So what is a container here? A container is a space for running a Java application or running any jar. Okay. So basically this container is going to depend on only 4 resources: CPU, memory, disk, and network. How a container can create? By taking some certain part of our system memory, by taking some CPU, disk, as well as the network to connect to Docker network. That's all. Okay, so only these 4, and these are something called kernel system. Anyone knows about operating system kernel? So in our, let's say on our laptop machine, there is a Windows operating system. Every operating system has a core part. Let's say if you just take Spring Framework, there is a core library where we do have some annotations like @component, @controller, @service, @repository. All these annotations are from core library. Likewise, in our operating system, there is a core part: CPU, memory, disk, and network. Without this, there is no operating system. These are actually the main parts of the core operating system. And Docker exactly takes the help of these 4 resources in order to run Docker images as containers. So Docker image is just like a jar file. When it is going to run, it obviously becomes a container. That's the total idea. Okay. And now, okay. So how to create a Docker image? Okay. So right now, in order to, let's say I have Docker. In order to run a Java application, do I have to install Java on my machine? If I want to run a Spring Boot application, JDK is required, but Docker does not require JDK.
But operating system internal memory.
No. Docker container operating system is different. Our local machine operating system is different. Docker itself has its own isolated environment for containers, creating Docker containers from images. Okay. The total idea over here is whenever we run a Docker image, it obviously becomes a container. That means certain part of our memory will be taken by the Docker container to create a platform for running Docker images. That's the total idea.
Nothing but like JDK.
Yes. No. I will tell you. First of all. So here, we will see this, how to create Docker images and all this kind of things maybe tomorrow. To create a Docker image, you need to write a special script called a Docker file. in our application root path. This file specifies the application base image, its dependencies, and the commands to run when the container starts. Okay. So these are all the things, but don't worry about this. We will just see this tomorrow. And I just wanted to tell you about the benefits of Docker for Spring Boot applications. It actually simplifies the deployment. Let's say there are so many environments, dev environment, QA environment, test environment, prod environment, right? So we need to deploy our applications in different environments. So probably we can have something called, Docker Compose files. I will tell about Docker Compose tool maybe tomorrow, not now. So basically, if you just wanted to deploy your applications on different environments, Docker simplifies the deployment with Docker Compose files. And there is something called version control. So right now, if you just see my GitHub repository, there are so many source code repositories, right? If I will just show it to you. So let's say first day I have committed one single Java file. Second day I have committed 3 Java files. Third day I have committed 4 Java files in my GitHub. So what happens? If I have to go to specific commit, I can just go to specific commit where I have committed only one single Java file, right? So likewise, Docker images also has specific versions. If you see about any of the dependencies, every dependency has a version. Likewise, Docker images also have versions. Okay. So next, isolation. So each container is isolated, ensuring that changes in one container do not affect other containers. That means when we are going to run Docker image as a Docker container, and we are going to run the same image again as a different Docker container, it will run on different ports. That means 4 containers are going to run. If I just wanted to run my Spring Boot Docker image 4 times, 4 containers will run. Each and every container is isolated from each other. That means there is no disturbance. That means one container cannot affect another container. Right. No. If it is same port, it will run in the same container, right? If it is different port, then probably it will take another container and then it will run the application. Right, the same thing, whatever you said. Scalability. So here Docker containers can be quickly scaled up or down based on demand, making it easy to handle various loads. Right now we have actually increased our applications to instance 1, instance 2, and instance 3. But Docker has some special commands where we can actually scale our applications to 3, 4, 5, 6, 100, 200, 300, something like that. We can actually create n number of instances for our Docker images. Okay. And then there is something called a collaboration. So I just wanted to explain about this collaboration. Docker images can be shared via Docker Hub or other container registries, facilitating collaboration among developers and teams. Okay. I'll tell you one simple example. Tomorrow, when I'm just showing it in practical, I just wanted to uninstall Java on my machine. And let's say I just wanted to develop on Spring Boot application. And then when I run that application inside a Docker container, it doesn't need that my operating system is having JDK or not. Docker container has to install the JDK, not our local machine. Because, right. Okay. So Docker container itself has to maintain and install the JDK. And if you just see this is a Docker official site. Okay, make better secure software from the start. But here there is something called a Docker Hub. So let's say I just wanted to open JDK. Docker, open JDK. If you see here, OpenJDK is a image provided by the Docker Hub, hub.docker.com. So this hub is going to contain lots and lots of softwares. Right now, how you are actually installing Java? We are going to this. We are just clicking on this downloads, right? But if you see this, we cannot download this directly. We need to use Docker pull OpenJDK. But this command will work only inside a Docker container and not on our operating system.
Not on local machine.
Not on local machine. It will run only on Docker. That's the total idea. And this OpenJDK will create a JDK environment inside the Docker container to run our Java applications. That means even if I uninstall Java on my local machine, it will still work because inside a Docker container, the OpenJDK image will run as a container and our Spring Boot application is going to use this OpenJDK environment to run our Java applications. So that's the total idea. Okay. So that's why here there is something called collaboration. Docker images can be shared via Docker Hub or other container registries like we are going to use AWS ECR, which is Elastic Container Registry, which is specifically designed by Amazon to store our Docker images, facilitating collaboration among developers and teams. That's the total idea. So here, if I just share the Docker image to anyone, they can run the Docker image as it is a Java application or a .NET application, no matter whatever the kind of technology it is, it will have certain instructions defined in the Docker file. I'll tell you tomorrow in practical scenarios. Okay. So that's the total idea about the Docker. And then probably if you have any questions, you can ask me. But make sure that tomorrow join at least by 9 a.m. or 9:05 a.m. It's a request for everyone.
Like we can say, Spring on top of Spring framework, Spring Boot technology was developed. So in the same way, on our local operating system, it will consume some memory. On Docker image, internally it will run OpenJDK. So
Right.
like same way.
Yes, tomorrow you will get to know more about these things because we have not explained or gone through these practical things, right?
Whatever you demonstrated to you on Docker.
Any questions from anyone? First of all, no one wanted to ask any questions, first of all, but try to join at least very early tomorrow. This request from my side again and again, okay? Because we have started the session at 9:30. Okay. I will tell you when you have to install Docker. I will tell all the kind of things. Okay. So Sunil Kumar Mangalam Palli. So real-time project prerequisites is you need to only have the core Java knowledge. That's all. You don't need anything else. If you're really strong in core Java, then probably this training will work out for you, Sunil. If no one has any questions, then probably we can wrap it up for today. If you have any concerns, kindly raise your hands. Okay. Suresh Prasad.
Oh, I have a small question. Since we are using Docker, right? So do we have any specific system requirement, or we can any laptop with 8 GB or something to work?
No, I think 4 GB or 8 GB RAM is enough, Suresh, for Docker.
Okay, thank you.
Even if it is 2 GB RAM also, it is fine, but it will actually slow up your system.
And we can use it to any like Windows or Mac. Which one do you advise to run?
Anything is fine.
Anything. So.
Yeah.
Okay.
So we do have Docker for Mac as well as Docker for Windows, as well as Docker for Unix also. Saho?
Yes, sir. Are you covering join one to many, many to one, and join query these all the things?
Sure, Saho. We will be covering that. Okay. Don't worry.
Okay. Thank you.
Yeah. Thank you, Saho. Naresh?
Yeah, good morning, sir.
Yeah,
Thanks
hi.
for the session. And the intro point of view, you can say they will ask like what difference between Kubernetes and Docker.
Hmm.
So which one is better when we so nowadays is in place of Kubernetes, most of guys are using Docker, right?
See,
What
basically,
is the main
Docker is a
advantage or the
containerization platform. Kubernetes
okay?
is actually used for orchestration purpose. But you will come to know about all this kind of stuff once we actually cover Docker.
Okay, okay, sir. Thank you.
Okay, yeah. So Kubernetes is basically a cluster. It provides a cluster where it actually makes sure that at least one instance of our application is running instead of making the whole application as down.
Okay, noted.
But in Docker, there is no such technology. We can make sure that if we just wanted to run 10 instances or 20 instances of our application, Docker is going to provide that kind of stuff to run our application as 20 instances or 30 instances to scale up or scale down, something like that.
Okay, sir. Thank you.
Yeah. I think that's all today. No more questions from anyone. Abhinav Bellamkunda. Yes, Abhinav.
Hi, sir.
Hi, Abhinav.
So the query is actually the whole project is going to have a lot of technologies, right?
Right.
So I was trying to make it in Mac. Is there any difficulty level will be more if I am trying to make this in MacBook?
There will be no concerns. It will work exactly on a MacBook on how it is working on Windows as well, because we have this type of softwares to be installed on Windows as well as on Mac. So you'll not be getting such issues. If you are
Okay,
able
sir.
to get, because I use my personal system Mac, but actually SAP has been installed on my Mac. I don't want to disturb that for some few days because my sister is working on SAP technology. So that's the reason I'm not using my personal laptop for these demo sessions. Not for demo sessions, for this training purposes. Okay.
No worries, sir. Just like
But if
I'm
you
scared because configuration will be a little different from Windows,
Oh,
right?
no. In Mac, the software installation will be very much quick. But in Windows,
Yeah, yeah. Yeah.
okay.
Okay, thanks.
Yeah, thank you. Sunil? Hi, Sunil. Any questions from your side? You can just unmute from your side. I have given the request. Okay. No, no, not required, Sunil. I will tell you each and everything from the start. This is a starting day, right? So don't worry. So everything will be discussed from the start. Okay, how we are going to set up the gate, how we are actually going to install Maven in our system. Everything will be taught to you. I'll tell you about that, Teja. Okay, I will tell you about that. There are two ways of communication between Docker containers. One is through IP and another one is through network. Okay, so don't worry about that. I'll tell you everything. So when will we start actual content of mini project? We'll start the actual content from today itself, because we need to actually start doing some practical examples on Docker. So once we do that, we will move on to the mini project Akash. There will be no delay. It will be maybe 4 to 5 days. We will just be concentrating on the basic, and then probably from next week, probably we will start the mini project. But before developing a mini project, we just have to get some hands-on on Spring Boot, Spring Cloud microservices and all these kind of things, Akash. Okay. Okay, thank you. Yes, we can access it, Teja. Okay, I'll tell you how to do that first of all. Okay, I think that's all the questions. And in major project we'll use IntelliJ. We'll be using we'll not be using STS. We'll be using IntelliJ only, Gaurav. And I will tell you how to install IntelliJ and how to create a project, how to import a project, and also how to create a Maven multi-module project also using IntelliJ IDEA. I will tell you each and everything. Yeah. Okay then. Thank you all and have a great day. We'll meet you tomorrow for the practical hands-on approach using Docker. Okay. Thank you everyone and have a great day. Bye.